Okay.
Here's what I'm going to do for the next few days. Instead of having a canned problem of the day, I'll take a problem from the text. So are there any in particular that you'd like me to, we're not going to do it today. Any in particular that you'd like me to go over? So were there any on the test that you can recall that you say, hey, I would like to see that one explained? Number 8. Well, now that was, did I let you do that for extra credit? Okay, so 8, that was not assigned, right? Any others? All right. Okay, well, if you think of some, I could use those. All right. I'll just do a quick recap, so hopefully it makes more sense in the notes. What Euler's method does is it mechanically reproduces a function. So, you start out at a certain point, well, let's just start out here, and that's the value. Then what you do is you take the slope of it and extend it out to a certain point and create a new point. So this would be y sub 0, this is y sub 1. Then you take a slope and extend it out a little further, and that's y sub 2. And then you take the slope at that point and get y sub 3, and it goes on forever. What it's doing is it's using linear approximation. It's taking a line at that point, and then it's going to this point using the slope and making the slope. Then it's using this point, taking the slope there, and making the slope, and it's mechanically creating the function. All right? Linear approximation, if you can recall, was take the value of a function at some point, add to it the derivative at that point, and then take the difference between x and x sub 9. So this y1 is found by figuring out the value at y sub 0 plus the derivative back here at y sub 0, and then multiplying it by the distance between these 2 points, which we'll call dx. And so there's the formula that you use for Euler's method. Then, how do you get to this point, right here? You get to that point, y2, by going back to the previous value, which you just found, find the derivative at that previous value, and then multiply it by dx. How do you get to the next point? Same thing. You take the value that you just found, add to it the derivative at that point, and then multiply it by dx. And of course, if the dx is small enough, this mechanical creation is pretty good close approximation of the function itself. All right, the example that I gave was we know the derivative is 1 plus y, and we know the beginning value was 1. So let's create the function that's produced by this derivative and initial condition. We know the initial condition. When x is 0, y is 1. So this is y sub 0. It has a value of 1. Okay? What's the new point out here? And they said let dx be 0.1. So now what we're doing is we're going out here to 0.1, and we're trying to find where's the next point on the function, or the mechanical function that we're creating. Right? The actual function looks like this, and what we're doing is we're creating a mechanical function that's pretty close to it. That's what we're doing. All right, so how do we figure out y sub 2, or y sub 1? That's what this is going to be. y sub 1 is the previous value, which was 1, plus the derivative at the previous value. The derivative at this value here would be 1 plus whatever y is, which is 1 plus 1, times the distance between the points, 0.1. And I believe it comes out to be 1.2. So this point here now is 1.2. Yes, Emma?
Wait, how did you get the 1.1 as the derivative?
1 plus 1? The derivative is defined as 1 plus whatever the value of y is.
Oh.
Okay? So now, let's figure out what the next point is. Where's the next point? Y sub 2. Y sub 2 is we go back to the previous value that we just found. Well, the value that we just found is 1.2. Then we take and multiply by the derivative. The derivative is 1 plus the value that we just found, 1.2. And then times 0.1. And then that gives you 1.44, was it? 1.42. Okay? Yes, Emma?
Will the derivative always be that, or is that just for this?
That's for this problem.
Okay.
That's for this problem.
Will that be given in every problem? Or
Well, usually what happens with Euler's methods is you're given a derivative, you're not given the function.
Okay.
And so you're given the derivative. With that derivative, you're creating what the function would look like. Because the only thing that we know about the function is that at 0 it's equal to 1. We don't have any other definition.
Some of the problems that you don't get like the dx, like so you choose what you
Choose,
dx?
yeah.
Okay. So you can just choose it to be 1 and make it
Yeah,
really,
yeah.
really easy.
Yeah.
Okay.
You want to make it accurate, you want your dx's to be fairly small.
Okay, so 0.1 vertical too.
Yeah. All right, and then finally, how do we figure out the next point? This is y2, this is 1.42. Where would the next point be? Y3. Well, it's the previous value that we just found, 1.42, plus the derivative, which is 1 plus the value that we just found, 1 plus 1.42 times 0.1. And then that equals 1.66. And then that's, in your assignment, that's all you had to do was go to 3 places to create. Okay. Now, this particular one, you can actually solve. And so that's what I did in the notes. I took y prime equals 1 plus y, and y of 0 equals 1. Well, what's another way of writing y prime? dy dx. That's a differential equation. How do we solve differential equations? Separate the variables. So you put all the y's together. So dy over 1 plus y equals dx. And then what do? You integrate. I didn't write the integration symbol in my notes. I should have. Sorry. All right, what's the antiderivative of 1 over 1 plus y? It's a natural log of 1 plus y. It looks confusing, but it's basically the same as the integral of 1 over y, which is the natural log of y. It's just this is 1 plus y. Antiderivative of this is x, and then plus a constant. All right, what does this mean? It means that 1 plus y has to equal e to the x plus c. Okay. So y equals negative 1 plus e to the x plus c. What can you do with the plus c? Make it e to the x times e to the c. So we get y minus 1 plus e to the x times e to the c. And At this point, now you can plug in the initial conditions. Put a 0 in for x, put a 1 in for y. And so e to the 0 is 1, e to the c is now 2. Which means the function that has this derivative and has that initial condition is this thing right. I add 1 to both sides.
Okay, now I see.
And then e to the 0 is 1. So e to the c is 2. So I can rewrite this now. I should have c. So I can rewrite this y equals -1 plus, this is now to be replaced with a 2 into the x. If you plug this in your calculator, it'll give a function that follows those points that we just created. Okay, that was a little quick, but we've had a day to kind of digest it, so does it make more sense? Any questions? And then they said something about Euler's method in the book. You don't have to worry about improved Euler's method. Just being able to do it out to 3 places shows that you have an understanding of what we're doing. And you won't be tested on it. All you have to do is get that assignment done. All right? That'll be part of the notebook check for chapter 7. Okay, ready to go on to 7? Good, so am I.
We're out to get started. Oh my God.
It's so easy.
Looks like like you went to a different country.
It's basically,
It feels like a different
it's like
country.
2 whole hours.
So really, you do realize that
Two times over.
you do realize that you got 2 of them. Yeah.
No, I didn't.
Yeah, you did.
Are you serious? They add 2 hours onto what time.
Chapter 7,
not get
section 1.
It works backwards.
Is basically using or understanding integrals as a net change. There is really nothing new in section 7.1. It's just understanding what you're doing. All right, so I don't have any notes, it's just some examples. So the velocity of a particle is equal to t squared minus 8 over t plus 1 squared centimeters per second for the time period 0 to 5 seconds. Okay? We'll do a couple things with it. Okay, first question is describe the motion. V of 0 equals -8 centimeters per second. Describe the motion. What does that mean? It's a simple answer.
Moving at a constant velocity.
It's moving at a constant velocity of what?
8 centimeters.
Where?
In the
negative.
Right. So basically to the left. So it's just moving to the left. 8 centimeters per second.
What if it's moving down?
Well, we're talking about particle right and left. You get more specific if you want it. If you put 5 in here, it's 24.8 centimeters per second. What does that mean? It's moving to the right at 26.4 centimeters per second. Very, again, just understanding what the thing is saying. So it's moving to the right. And if I put in 1.25 seconds, I get 0. What does that mean?
Changing directions at that point.
Yeah, and it's what?
Stop.
It's stopped. It's not moving. And maybe only for a brief instant, but at that particular moment it stopped. Because it is indeed changing direction. Okay. Now, let's try this one. If its position at the beginning was at 9, find its position at 1 second later. All right. What are we going to have to do? We don't have to limit because we're not going to infinity. Integrate what? Okay. Change what velocity is. What's velocity? It's the rate of change of its position or distance. So velocity can now be written as ds dt, and then it's this equation. Now if you say the word integrate, it makes a little more sense, but we still have to do what? Separate the variables. And so that means there's no s's, so that better be by itself. And the t's, of course, over here. Now what?
Integrate.
Integrate it. So the left side is easy, that's s. What's the right side?
T cubed over.
T cubed over 3, that's easy. This one looks messy, but it's really not very hard.
Minus 8 times the natural log of t plus 1 squared.
Natural log only works when it's a linear expression on the bottom. Okay?
Oh, you take the negative.
It's a lot easier to visualize if you don't treat it as a fraction, but treat it as a expression with a negative exponent. Now we're looking at the antiderivative of this. So that means it's a power, so it's 1 power higher, which should be t plus 1 to the negative 1. And we want the answer to be a negative 8. So it's just a positive 8. So this now becomes plus 8 over t plus 1. And then what else? Plus a constant. All right? So what's the constant going to be? Is it going to be 9? We get the constant by plugging in a 0 for time, a 9 in for the distance, right? So we get 9 equals 0 plus 8 divided by 1, right? So what is C? C is equal to 1, right? Okay. So its position after 1 second would be t to the third over 3 plus 8 over t plus 1 plus 1. So we're looking at 1/3 plus 4 plus 1. 5 1/3, right? Okay, nothing new, just using what we've already learned. Okay, what was happening during this time period? It was moving to the left, moving to the right. So it started at 9, it finished at 5 1/3. Is that how far it traveled? No. So, question C, how far did it travel? How would you solve that?
Find what goes to 0.
Pardon me?
9 minus 5. Find what it changes and add
It's 5 thirds.
3 and 2.
How would you figure out the total distance?
Starting distance minus the second one.
You see, it started at 9, and it ended up here, but it went to the,
But it goes to time too.
Also,
it went to the left for a while,
Good, turn it around.
and then it turned around and came to the right.
Oh, when it goes to 0,
It did
add
not
one.
go anywhere.
We need to read the function to see if it did that.
Can't we just do
Wait,
Times are really fine.
Oh,
Emma.
but then it goes 1. So it has to turn around. How far did it travel after one side? You take
It's a video game.
Okay, all right.
Maybe it did it twice.
Oh my god.
Okay, I'm sorry. Logan had pointed out that from 0 to 1, it didn't change direction, so it would have been just the set time, set distance. So, how do you figure out the distance it traveled from 0 times 0 to 5? 2 ways of doing it. What would be one way?
Integrate.
Integrate from,
0 to 5.
no,
5.
from 0 to 1.25, and then 1.25 to 5.
Or can you take absolute?
Or if you have a calculator, you would just simply go from 0 to 5, the absolute value of the function, c squared. Okay? Remember that if you're doing problems with the calculator, you have to understand what you're doing, and instead of breaking it up into 2 separate, do it all by hand. If you can use a calculator, you simply take the absolute value, and then it would give you the total distance, because it would give you the positive distance of the whole thing. Okay? And this turns out to be 42.586, which would be the same thing had we, except we have to worry about the signs. From 0 to 1, 2, it looks like it's negative. So we probably would have to go negative for that answer. Yeah. Put the absolute value on the Okay, any questions on that? All right, next one.
I'm okay if they gave me like
You go with your
there's a difference between going 2 hours that way and all the way around.
It's 8 hours that way. And 2 hours that way. Come back. Yes, you get 2 extra.
Next example.
You get 2 hours.
A car moves at an acceleration of 2.4 times time.
Forward 2 hours.
Get on the car, would you? All right. Car moves at acceleration of 2.4 times time, and its initial velocity is 5 miles per hour. How fast is it going at 8 seconds?
Well, it depends on anything in
All right.
Next to Alex.
How fast is it going? So we're looking for velocity. So we need to come up with velocity. How are we going to come up with that? dv dt is another way of writing acceleration. Now it's pretty straightforward what you have to do. Separate the variables and integrate. Okay. That you should be able to do. What did you get? 1.2t squared plus a constant. And the constant is 5, because if we put a 0 in for time, the velocity must be 5, which means the constant is going to be 5. So our velocity formula is that. Okay, next question. How far did the car travel? Oh, okay, what did you want?
We forgot to actually plug in 8.
Okay, so now we need to plug in 8. So the velocity for 8 seconds is 1.2 times 8 squared plus 5. And then we get so 81 point. Now, notice that we did this by hand. We could have integrated on our calculator 2.4t dt and gone from 0 to 8. And you know what it had given you? What do you think it would have given you? Because that is only the change of distance or speed from 0 to 8 seconds. It was already going 5 miles per hour. So you can easily solve this in your calculator, going from 0 to 8, get a number, get an answer, but you have to remember, hey, it was already going 5 miles per hour, which we took care of when we did it with an indefinite integral. We okay? So again, understanding of what you're doing. You can easily do this on your, you wanted to do it by hand, you can do it on your calculator, but then you must realize that that answer is the net change in speed plus the 5 that it was going to be. All right, how far does the car go? And 8 seconds. Let's continue with this process here. So what do we change velocity to? Ds dt. Ds dt equals 1.2t squared plus 5. Separate the variables. All right. Now let's integrate. What's this? T cubed 0.4, very good, plus 5t plus a constant. What's the constant coming here?
Yeah, we need some sort of, I don't know this one.
Well, we basically the distance is 0 because we're going from for 8 seconds. So it doesn't matter how fast it was going. It's when we start calculating the distance. So the distance would be 0 when the time is 0. So 0, 0, 0. C is 0. So the distance that it traveled is 0.4 t cubed plus 5t in 8 seconds. So 8 cubed plus 5 times 8. And give me a calculator.
Yeah,
What do you get? 244.8. In 8 seconds? Something's wrong here. How far did the car go? 244 miles?
Hot dang.
Oh,
They
yeah.
like, uh-oh.
Or multiply that.
No. It's 244 miles per hour times seconds. And what do we want to get rid of? The hour and the seconds, right? We just want miles in our final answer. So how can we get rid of? This is miles per hour, so the hour basically is on the bottom. Miles per hour times 8 seconds. See if you went 10 miles per hour times 8 seconds, or 8 hours, the hours would cancel and you'd get 80 miles. But we're not multiplying it times 8 hours, we're multiplying it times 8 seconds. So how are we going to get rid of the hours and seconds? 1 second, or 1 hour, the hours will cancel, is the equivalent of 3,600 seconds. 1 hour.
1 hour is 60 seconds.
Hours cancel, seconds cancel, leaves us with just miles. And doing that, you get 0.068 miles. Okay, again, everything we did is not new, but you got to be careful that you understand what you're looking for. If we were not multiplying miles per hour times hours, it was times seconds.
If you just converted 8 seconds into hours, would that
You'd
work?
be fine.
Okay.
Yeah. If you would have just converted 8 seconds to an hour and then just plugged the hour per time, you'd be okay. Okay. The only section in this chapter that's not new, everything else will be new.
Online, you entered my test score. You got lower than that section.
Lower than your actual score?
What?
Lower than your actual score?
Way lower.
All right, look and see.